Hello, I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 5 a.m. on Saturday in London. We're broadcasting live from Thousand Oaks, California. Thanks to all of our participants and subscribers. Over 85% of our viewers have not subscribed, though. If you watch 2 or more episodes, please consider subscribing.
Okay.
You want to say hi to people?
Yeah. Well, Cliff's here.
Hey, Cliff.
Yep. It was pretty cold in Michigan, not so cold in Washington State. So I got to thaw out partially on my way over this way, back here. Oh, yeah.
Yeah.
Yeah, I like see merging galaxies and just what we can learn from
It's a
it.
nice little project.
I think for the most part.
I think they are. We had about 24 hours of rain,
Mm-hmm.
and I think it got most everything in the whole area.
And no wind spreading it, so.
Yeah, thanks for asking.
Mm-hmm.
You've got a cybersecurity news.
Yeah, Apple products. There's a couple of things going on, but one of them's a pretty big flaw with their Wi-Fi drivers. It's fixed. If you've got Apple anything, look for updates.
So yes. iPhone, iPad, iPod,
Yeah, if you've got an iThing, yeah.
If you've got an iThing, yeah.
And oh, yeah. Hey, Janie.
Hi, Janie.
Yep.
Yes.
Yep.
We are too.
Yep. And Cliff's is.
Yep. Yay!
Yep. Wasn't he the first?
I don't know. There's a whole list somewhere. I could
Cliff,
look.
You were either first or second, and I can't remember off the top of my head, but
that was like 40+ years ago.
But,
Thank you very much. We really appreciate that.
Also, in the realm of cybersecurity, Android has had a update. I don't know what for, but my guess would be it would be a security issue.
I think most of them are. So if you got something and you see an update, you usually want to make it happen.
Some updates are simply to remove features.
Okay. I didn't know that.
Yeah.
Hey, Scott's here. Hey, Scott.
Yeah, if you've got a Synology backup system, yeah. The latest update just removed features.
Oh.
Yeah, hey, Scott.
Oh, welcome, JY.
Well, yep. Hello, JY.
I think that's a first-time visitor. Thanks for being here. We appreciate that.
Yep.
All right, so tonight's episode is Cosmic Disco, Characterizing Galaxy Collisions. We'll be back in 8.3 seconds. There's a link to that book in the description. Studying collisions between galaxies, galaxy mergers, have transformed our understanding of the universe. With your help, we hope to better understand the connection between mergers and their role in shaping galaxies' evolution. And that's from Zooniverse. Okay, Jeff, what's this project like?
Well, it's standard Zooniverse, and if you could share it, please.
Yes.
There we go.
Click the right one.
You know, all of this looks pretty familiar to any of you who've either been on Zooniverse or watched any of our videos about Zooniverse. Cosmic Disco, Characterizing Galaxy Collisions.
I love the names of these sometimes.
This is something interesting that I found here. This check mark. Oh. Zooniverse approved.
Okay. Don't they approve them all?
I was wondering, aren't they all? But maybe they've actually reviewed it and decided, because you can put your own project together and put it up there. So maybe they're making it more open and thus are saying which ones that they've specifically.
Okay.
But I'll have to look more into that. I found this yet today, and it's like.
And I don't remember seeing that. So
yeah.
Good catch.
Okay. So again, standard about classified talk and recent. And these are various images of galaxies.
And I'm really glad
What?
it's still here to work on, because it's not always.
Right. Yeah.
It was 0% when we started, so only 1%. They got quite a bit of work for you.
Yeah. Yeah, there's a lot. Oh, okay. And it was, when we started, it was 0% and 40 completed subjects.
So 106 now. Got it.
Yep.
But a lot of people are working on it.
Yeah. Yeah.
So it's good.
Yeah. And
I read part of that.
yeah. Basically, these efforts help us train automated machine learning methods that can tell if a galaxy is a merger or not. However, we're helping them. Hey, Don.
Hey, Don, welcome.
Yeah. So basically, we're now in the about, and I'll start there because, come on, our project about.
Oh, that doesn't work. Oh, I've seen those across the top, like a nav bar.
Yeah, right there. That one works. That's weird because it worked. It worked
yesterday.
Yeah,
it worked for me earlier too. But that's a Zooniverse about.
Yeah. Oh, yeah.
It's not the subject about.
Hang on. Maybe refresh.
Oh, yeah. That often helps.
There we go.
Yay, team.
I'm in IT. Refresh the page. Does that, number one, right after like rebooting the computer or whatever, yeah.
Yeah, sometimes the best advice is
reboot.
Yep. Yeah, it's amazing.
So that's the web version of rebooting. Okay, this is kind of basic. Galaxy merging is the process in which two or more galaxies in the nearby vicinity interact due to gravitational forces and collide with each other to form a single, more massive system.
I think we know something about galaxy mergers. We're kind of in the precursor of one with the Milky Way and Andromeda. I mean,
yeah, and there's
really early days,
and we have a bunch of dwarf galaxies that are the remnants of collisions.
He's ribbing you. More to thaw out, Jeff?
Yeah. But one of the things that you have to be aware of is that a galaxy, and I like their term galaxy mergers rather than galaxy collisions, because the chance of anything actually hitting anything during that whole process of really is really small. They basically pass through each other and affect each other gravitationally as they circle in on each other.
Yeah, I was going to say gravity, but just an actual collision of stars.
Yeah. Yeah. And basically they're out to find the stage of the merger. And
okay. That's beautiful. That's Starburst Galaxy.
Yeah.
Wow.
Yeah. And I kind of like this one just from the simplicity of it. Yeah. Just from the way it's kind of, you can see that it's slightly deformed. So you can see that it, that it did have some kind of event. So, and this is how they determined whether they're merging or not.
I do like that they generally offer you some a little more technical data, right, and so you can delve into it as much or as little as you would like.
I think that, and I'm going to give a little bit of critiques here and there on these guys. I think that this could have been explained a little bit better.
Fantastic photos. Yes, Jeannie.
Yeah.
That's one thing about this area of interest we have is really beautiful imagery.
Yeah. So this is really nice and all. I think it could have been explained a little bit better.
Oh,
but,
okay.
But they're talking about, they took information, photos from a couple of different, observatories out there. Sloan Digital Sky Survey.
We're kind of familiar with that from past.
And where's the other one in here? Oh, come on. It's in here somewhere. Or maybe it's a different section.
Cliff says there is basically no way two stars will collide.
Yeah.
I know that black holes have.
Right.
Are they stars though?
Well, it's not no way. It's,
looks cool.
The
though.
universe is big, but it's not likely to happen.
Yeah.
Kind of like in a shooting war, they have instances of bullets hitting each other. Now think of how small bullets are compared to the amount of space. Actually, it is more likely for bullets to hit each other. But if those can do it and have significant numbers of them doing it, there's got to be stars that have done it. Will we likely see them in our lifetime anywhere near us? Nah.
It does look cool though. You're right, Cliff.
Yeah.
Okay, you ready for?
Yeah.
And when you find that, just shout it out. What the?
Yeah.
So Sloan Digital Sky Survey.
Yeah, it might be a different area because it might be in the.
Okay.
It might be up in the FAQ.
Fair enough. Yeah, FAQ.
Yeah, but they took two of these observatories. One is the dark matter survey, and basically compared the two.
Okay.
So then we go the team.
Hey, the team, and you've actually been in touch with the lead, right?
Yeah. And we'll see. I mean, try to rope in guests whenever we can. And
oh yeah.
And I'd be very interested in some of the background for this project.
Oh, okay.
And a little bit more on what they're hoping to get out of it. Because that was a little bit general about what they're hoping to get out of it. Oh. Now, it's always possible that they're just trying to create a tub of data that other people can use for whatever they're looking.
Well, when Sadie came on, their students trying to, enhance their degree or get their degree. It's their dissertation or whatever. Cliff says black holes attract each other because of the mass and gravity.
Yep. But stars could do the same thing, just on a smaller scale. So possible.
Yeah, I could see that happening. Again, the odds are not necessarily great.
Right. Especially at the speeds that they're going. Black holes attract stars and stuff mostly because they're in the same vicinity and probably orbit around it in a decaying orbit or swing past it at a relatively slow speed. Galaxies going past each other are actually going past pretty darn fast. So the chance of affecting each other gravitationally is really small. So yeah, it's not likely. It'd just be the magic bullet type of thing where they'd have to just happen to be right on the collision course.
I can totally imagine that closer to the core of the galaxy things are happening.
More likely.
We're not going to know about. We're kind of out in the boonies.
Yeah, it's more likely. I mean, it's a target-rich environment essentially.
Yes.
Still, they're pretty far apart, even in the core.
Yeah, I get that, but still.
So.
All right, so you ready for more?
Yeah.
All right, go ahead there we go.
Okay, and here's the fact. I'm not sure about the class of a galaxy merger. What do I do? How do I use talk? Okay. Once you select done and talk, this is generally, this is generally Zooniverse type of, stuff. But this is good.
Sort of standard for the site. Okay.
But it's nice that they're talking about the talk part because not all projects, all projects have the talk. Not all of them actually talk. So.
Okay.
That's, this is good. How is the data selected?
Maybe it's in there about
or one of these, Our galaxies were selected by the Sloan Digital Sky Survey data release 17.
Okay, so they specify which. Okay, I don't think I realized there were.
Yeah, we
like maybe versions.
Yeah, we specifically require that our galaxies be relatively in the nearby universe, and have a high quality spectral lines, a signal to noise ratio of greater than 5.
Cliff makes a really good point here. There is so much space between stars. There's not much to hit. We would see explosions in merging galaxies, but none. Yeah, you make a really good point.
Yeah. Well, we do see star forming. So, yeah. It can't say that it can't happen, but it's probably not likely. Um, so basically, they're looking for things, have high quality spectral lines so that they know the speeds of them,
Okay.
and it's not just fuzzy of, yeah, they might be sort of kind of merging. They want to find ones that, yes, they are merging.
Okay.
Where do the images come from? Here's
there it is.
Cross-matched the SDSS-based data with the dark energy spectroscopy instrument survey.
There we go. DESI. Okay.
Yeah. And present you the images from the survey. These images. Okay, a little bit of grammar issue. Are deeper than the SDSS images and are ideal for noticing faint and diffuse features, such as the one caused by galaxy mergers.
Okay.
What machine model was used? Now this is interesting.
Oh, they don't usually talk about that.
Mm-hmm. Yeah, we used
Zoobot.
Probably developed on this site, but I don't know anything about it. I didn't delve into that.
Well, there's a link though, so that's cool.
Yeah. That's for later. And select those images that have high probability of being a merger according to it. Zoobot was trained on the volunteer classification data from several Galaxy Zoo projects.
Good to know.
Probably, probably the first one might have been in there.
Well, I'm wondering if they've been at it for a while, but they've just now decided to mention it.
Yeah.
I don't know. I will have to look into it some more.
Yeah. While using machine learning to pre-select mergers, our initial samples consisted of approximately 90,000 images, which is a small fraction of the potentially merging.
Wow.
Yeah. So they weeded out the stuff that is definitely not mergers. So thank you.
Yeah, the machine can do some things, but people are still really
when it
good
gets
at
close. And quite frankly, they're not so much looking for, is it a merger, but what stage of merger it is. And we'll get into that. So
it might be harder for a machine to do.
Yeah.
Don't know. I did some of these too, and I had a little trouble with some of them. Like, is it this or is it this? You'll see.
Although I will say that when she did them, her images were more interesting than when I did them, and we were a day apart. So
yeah,
doesn't
You'll get some good ones, I bet, tonight.
Classify. Let's do the tutorial.
Nice tutorial.
Yeah, it is a nice tutorial.
I really liked how it popped up to the top again on most of those screens. One
quibble, and this has nothing against the project or against Zooniverse itself. The scroll bar in Windows 11 is itty bitty.
Oh, they're all skinny as heck.
Yeah, and that's a Windows 11 issue. I hate that. But
it's annoying.
My gripe, but I'll be done with my gripe.
Okay.
That one at least. These almost always start with a welcome.
That's a pretty quick tutorial too. I noticed.
It is. I would say that it's either a little bit light or just the right size.
Okay.
But I would highly recommend doing field guide before you even touch this. Some of them, you get everything in the tutorial. This one, I think you really need the field guide. So
yeah, I didn't really look at the field guide. I did the tutorial and tried a few, and seemed to go okay. Yeah.
So when you go to the classified page, this is what you see. The option to inspect the galaxies and their hosted features by choosing between the zoomed in and zoomed out images.
And they've got 5 choices. That was at the top there.
Yeah. And indicated by the yellow arrows here, right here, these dots.
But they'll show up on a lot of the Zooniverse.
Yeah. It was definitely built using Zooniverse tools. Yeah. And then pre-interaction stage. This is when you see 2 or more galaxies that are in the nearby vicinity, but do not have any disturbed morphological features. Basically, if they're all circles or disks, but there's no twisting, there's no, no bending, then they haven't actually interacted yet.
Yeah, I noticed as kind of just stream or line of
Yeah.
material somehow.
Yep. Post-interaction stage is when two or more galaxies are distinctly separated from each other and either one or both display disturbed morphological features. Like, this one doesn't really, but this one has the swoop.
Yeah.
And this one looks like it got, spinning the wrong way. So if it's pre-interaction, meaning the cores haven't penetrated each other.
But the post interaction is they've just started to look like they're interacting.
Yeah. Near coalescence is when two or more galaxies that are very close on the verge of a single galaxy's size, or on the order of a single, or embedded within each other's light envelopes, displaying disturbed morphological features. It's kind of like this one, how there's this glow, but you can see the two cores right there.
Cliff says, just to let you know, a fifth new internet provider, and it's good, just always a 2-minute delay for comments.
Oh, that's better than 5 to 10 minute delay, so good.
And I heard you had some clear sky, maybe?
Wow. Yeah.
I hope it stays that way. Fingers crossed.
Yep.
Go ahead, Jeff, sorry.
Or at least once a week, right? So you can get out, so that you can pull out the scope.
Preferably on the weekend.
Mm-hmm. Post-coalescence stage is when the two galaxies' central core regions have merged into one, or are visibly indistinguishable in the image, and there are indications of disturbed morphological features. Because of course, if it wasn't disturbed, then it could be just a single galaxy. And I like the fact that they say that they've either been merged or are indistinguishable, because if from our perspective, if one is in front of the other, it looks like they're merged, but they're not. So, and there's no way for us to tell at this distance, I would imagine.
It's been okay, but cloudy.
Wow, this is not raining.
Not raining, yeah. That's an improvement.
Yep. So let's see. Sometimes you may see a single galaxy with no other galaxy in the vicinity, and is not hosting any disturbed or morphological features. This would mean that their AI pre-selection goofed and put in a galaxy that and you just say not a merger. Okay. Now I will say that I haven't seen one yet.
We're fine-tuning this process, apparently.
Yeah.
Okay.
Well, I haven't seen a non-merger yet. So
even the ones I looked at?
I didn't see all of the ones that you looked at. I just looked over occasionally.
I think you did.
Okay.
Because the first one I saw, I left it there because I wasn't sure.
Yeah. Okay.
Looks like you got one more.
Yep. And this is, you can view them. Oh, this is neat. You can view the metadata for the galaxy in the image by clicking on the eye button right here.
Eye for information.
Yeah. Which includes links to the external sky viewers. In the field guide, you can view examples and descriptions for each of the classification categories, along with some other information that you might find useful while classifying. And
it says bloody hot though. 70% humidity at 36°C. That sounds pretty warm.
Mm-hmm. Sounds like Michigan summer.
Yeah.
Although they get 90, so.
Yeah.
Not a merger, pre-interaction, post-interaction, near coalescence, post-coalescence, and stars in the field of view. And star-forming clumps. So let's go. And here's this. Let me just point out some of the things that they showed. These are the zoom out, zoom in. Now, if you notice this here, well.
Oh boy, that's a big difference.
I've very rarely seen stuff that is that you can only see in the merged out view.
Yeah.
But in this case, yeah.
Cliff said that's at night.
Yeah.
So it's warmer during the day.
Yeah. Okay. This is something that Pam saw that I didn't see. This invert image.
Yeah, it's basically just negative, light back, dark back.
And this, this is, if this might be easier for some people to see. They don't talk about this, and maybe this should be in the tutorial.
Show them the information one too.
Yeah.
I think that's cool because
Yeah.
if you understand that RA and DEC, which is right ascension, declination, it's
Yeah.
kind of like Latin longitude sort of spread to the
Mhm.
sky, and you can actually find this object if you kind of
Yeah.
know where to
Yeah.
dial those in.
Yeah, and they've got the object ID,
That is nice.
the
Cliff.
red, the red shift, and they also tell you viewing the legacy image viewer.
I think
the
that's a
search
Zooniverse thing,
yeah.
right? Does
Yeah.
the legacy image viewer?
Simbad, Vizier, NASA Ned Classic, but these are all astronomical tools.
So again, more ways to learn about this in depth. Love that about Zooniverse.
Yeah, and I really like the fact that they implemented this.
So what category would you call this?
Definitely post interaction.
Okay.
Because look at that.
Yeah, see, I told you you'd get a good one.
It's not near coalescence or post coalescence. But let's look at the field guide before we click on one of those.
Good plan.
Oh, they also have an artifact for bad image. I haven't seen one myself.
I haven't either. I didn't either.
So they filtered those out pretty well.
Yeah, I only went through about half a dozen, 10, something like that.
It's nice that they include that just in case.
Yeah.
So let's look at the field guide. Not a merger. Pretty simple. Not a lot of explanation needed for this one. It looks like a galaxy that's not bent out of shape.
So a galaxy.
Yeah. Pre-interaction stage. There, when you see two or more in the vicinity that do not have any disturbed features.
Wild that they're that close and they don't have any disturbed imagery to them.
Yeah.
They don't appear disturbed in any way.
Yeah. Oops. Oh, here's this isn't the project. This is Zooniverse. If you try to scroll this thing and you're at the bottom of it, it scrolls that.
Yeah, a lot of pages are like that.
Yeah, drives me nuts, but it's like that in all of them.
I hear you.
Post-interaction stage. This is where you get things where you can see that they've encountered each other.
Right. They're starting to share material.
Sometimes you may see one or both galaxies don't exhibit strong features that stand out, but rather a fainter fuzz. Here's an example. So take a look. You get these leftovers. Now, not quite what's going on here.
Cliff makes a good point. The large one has probably ripped a lot of mass from the smaller.
Yeah, it's likely.
That's a good point.
Yeah. One of the things that I would have liked to have seen in the field guide is what isn't a how do you tell that something's not post-interaction? Sometimes you can learn better from negatives, so that you can rule them out in your head. So in a lot of these, I think that would be a really good thing to add here is what's a feature of something that might look like post-interaction but isn't?
Well, if it's a typical Zooniverse project, there are multiple people looking at every image. And if there's any conflicts, then the scientists will take a look for themselves.
But it just would be helpful. As something that I found in some other projects that make it easier.
Yeah, that makes sense.
Post-interaction state. Oh, we already did that. Near coalescence. This is where they're, come on. This is,
That looks like it.
Okay, that's it. Okay, that's where, if you notice, they're really close to each other. They're within the,
oh, and see, I thought it was the blue one with that image. No, okay.
No, that's a star.
That's a star, yeah.
So, they're within the same glow, but they're still distinct.
And there's some mass around them that's not quite part of it.
Right, yeah. You can see the two cores.
So it's near coalescence, yeah.
Post-coalescence, no matter what the rest of the galaxy is doing, you pretty much only see one core. Now, I've seen some cores that look oblong in it. So that's still...
And here's one that would be nice. This isn't a single galaxy. I mean, it's basically becoming a single galaxy, but...
Yeah. So, a little bit more along those lines. And these are stars in the field of view.
Yeah, see, I didn't look at this, so that would have been helpful to
not merger.
know on the
yeah.
ones I saw.
Yeah, so.
Yeah, good.
And if you notice, stars are usually bright enough that they have these artifacts around them.
Mm-hmm.
Not always. Like, here's one that doesn't, here's one that does. But if you see that artifact, it's a star. It's not a galaxy.
Yeah. And it could be close enough or bright enough.
Yep.
To kind of blow that out.
Yep.
Okay.
And then star forming clumps. And you've seen this in one of the images.
Yeah, several.
Yeah.
Oh, Dawn says, I love the quality of this image. The large galaxy is very elongated.
Right, yeah.
Yeah, it's kind of an amazing looking galaxy in the one that he's working on.
Yeah. Now, these clumps tend to be blue because they're star forming regions.
Yeah.
So.
And young stars are more on the blue.
Yep. Okay, so.
Well, they got artifact or bad image on the bottom.
Yeah. Okay, yeah. And that's just an example of glitch.
Like I said, though, it's good to have it.
It's good to have it. I haven't seen them yet. So we will call this post-interaction.
I think so. Yeah.
Done.
This one's nice. You just work it out, choose it, done.
Now here, this one looks like a star to me.
Yeah, it does.
So.
Well, you've got something going on there.
Yeah. Yeah, because this got pulled out.
Excuse me.
So I don't know it might be this one. It's really hard to see which are in the same plane, essentially, which are actually nearby and or not, but it does look like this encountered something.
Yeah, that top one doesn't really distort it in any way. I mean, I don't think that top one.
Yeah.
But this is the task.
Yeah. Now let's see how it looks here.
Yeah, it's a little bit easier to tell.
I'm trying to find another galaxy. That's what I'm trying to do in this.
Well, maybe it's basically post-coalescence. I mean, it's the cores are together now.
Yeah, and
there's just some material that's swirling in eventually.
Yep. Either that, or that's just a really, really big star. Galaxy-sized star.
Okay.
No, those become black holes. They do not pass supernova. They're just black hole if it's got that much mass.
Okay.
Okay.
So neat project, huh?
Yeah. So let's see. Okay. So I'm gonna say this is my very first near coalescence. Well, although look at that.
It looks well, no, I guess there's some material around them, but
yeah.
I don't know. I think I'd almost go back to the field guide to try and figure it out.
Yeah. Except, you see, that's just it.
Is it pre or post?
Yeah. They're both really round.
Yeah.
But is this stuff just the shine from around them, or are these stars around them? If these are stars around them, then this is near coalescence.
It could be post-interaction stage even. I mean, but you know what? There's go scroll down because there's a talk. If you really need some help with this task, it's a link. It's a link. Need some help with this task.
But you can't do it until you've picked one.
No. The other one is stop. Needs. There you go. See, it's a clickable link.
Okay.
Okay.
It's just
not that helpful.
Yeah.
Okay.
So it actually looks closest to pre-interaction, except that near coalescence is kind of like here's clump, and glow around it.
Yep. Yeah. But you can't go down and talk. Oh,
I can, but I need to.
Well, you have to pick
one.
it first. Yeah. Okay.
So I'm gonna say near coalescence and be done on talking. Let's just.
Oh, it still can't pick it. Did you actually? I don't think it took.
Oh,
there you go. Now it's there. You go. Now you can talk.
See.
4 active participants. That's good to know. No comments yet. Oh, you can leave a comment. How cool is that?
Yep.
Yeah, I think that one's kind of hard to tell.
Yeah, I'm gonna bring up my keyboard.
Okay. And what are you gonna write?
can't tell if this is...
They got two options. Add a note about the subject or start a new discussion.
Right.
So I'd almost ask a question.
Well, this is the subject, so this is the image.
Yeah.
Yeah. So
I'm sure that'll be attached to the note that you send. Okay, so you say, is this possibly pre-interaction?
Yeah.
Okay. Halo?
Yeah.
Halo.
Yeah, for some reason.
I know. That's it. That's all you need.
Once I got off track, nothing sounded right.
Yeah. There is a halo, yes. Yeah. Around both cores. Yeah, I think that's a very good question. There you go. And you actually registered for this, so you might see a response at some point. Do those come to you by email to let you know they responded?
I check my email so infrequently
that's
that
true.
I don't know.
Doesn't matter. Okay.
Okay, so now there's no easy way back from here except for going here.
Oh, you couldn't do the back button?
Yeah. Okay.
Oh, now you have a new image.
Yeah, new image.
It looks complicated. Oh, I guess it's a star.
That one's a star, but I think that these are... But look at how this is kind of like going this.
Yeah.
You know, so this has been disturbed.
You don't think that could have just been the galaxy how it was?
Let's see how it looks like this. And look at how this is kind of disturbed.
Yeah. And stuff at the end on the bottom sort of hooks around a little bit.
Yeah.
I really like this way, the darker on the light background.
Yeah. Okay, zooming out doesn't give me anything. But yeah, so post interaction.
Post interaction, yeah.
Yeah.
That's what I would pick.
Yeah, when you found this reverse image, and they don't talk about it, but I think they should because...
Oh, but they're in all the Zooniverse things.
Yeah, I know, but it makes it much easier to...
Okay. Yeah, I like the light background better than the dark usually.
It seems to get better contrast.
Yeah.
Are we looking at a star?
That looks like a star to me.
Except that it's fuzzy around it.
I don't know.
See, there is fuzzy. It is fuzzy around it,
Yeah,
so it's not not a point. So I'm gonna say post. Well,
not too much disturbed.
No.
Janie. Let's see if Janie can help. That looked like the Find the Wandering Westways Poppy from AAA. Okay, I don't know. I don't know about that one. I know what Westways is. The AAA magazine. I used to get those.
Yep.
Find the Wandering Westways Poppy.
I'm gonna say post interaction on that because it looks like this has been somewhat disturbed.
Yeah, I don't know.
Or you know what? I'm not gonna mess up their data because I'm not sure. So I'm just we're gonna call it here then.
Okay. All right. So that's what you're gonna cover for this project?
Yep.
Yeah, it's a great project. I mean, it looks like it's good for you if you just like to kind of plunk away at something. It's not too intensely brained. You don't have to brain too much, but you would help the scientists to classify these emerging galaxies. Yeah. Still, it's kind of a broad spectrum of ways to help.
Not a lot of fiddly bits.
Yes.
Which some of them are like, do this, and then based on that, you need this, and then this. Yeah.
Oh, hey, James, welcome. Very interesting information about galaxies, but I just can't see anything hitting as things are so far apart. Yeah, I think you're right. The odds are very, very low for that.
Yeah. Well,
great job, Jeff.
Like I said earlier, they most likely just pass through each other, but gravitationally they affect each other and will eventually, become one galaxy. Unless one's moving so fast that it just zips past.
Blows apart the other one.
Or just zips past. Yeah.
Yeah. Okay, so we'll continue to watch for your comments, but I'm going to go over some stellar events this week. It's January 31st through February 7th. January 31st, Saturday, the moon ring conjunction, and Jupiter is 5.1 degrees north of Aldebaran. It's the beginning of the month, so remember, skymaps.com is a great resource for you to go and get a free 2-page download PDF file so that you can start looking for things in the night sky. It's a nice little journaling page. It's really simple to check off the different things you've seen naked eye, with binoculars, and with telescopes. It does help you observe, I think, and you can keep other notes, do little drawings, that kind of thing. I'm going to go ahead and mention the almanac synopsis. I did put it on the show notes, though, so I can actually read it. Venus continues its January prominence on the 1st, growing more brilliant to magnitude negative 4.8, enough to cast shadows. I did not know that would do that. In the opposite part of the sky, extraordinary celestial brightness fills the east at nightfall. While Betelgeuse, Castor, Pollux, and Aldebaran shine at magnitude 1, the stars Procyon, Rigel, and Capella surrounding Orion boast a magnitude 0. Now remember, the smaller the number, the brighter. Even brighter Mars blazes at negative 1, and Sirius and Jupiter dazzle at negative 2. The celestial eye candy continues all month, while Mars slightly fades to magnitude 0 as it stands stationary in Gemini. On the 24th, Mercury and Saturn meet very low in the west in the bright evening twilight, a treat for those with an unobstructed view of the horizon. I thought we
not us.
Oh yeah, well, we can find one. Yeah, we got a comment.
It will turn into a great stir fry.
What?
All the gravitational interactions in all those stars. Yeah.
I like that. I like that comment. Yes.
Well, I think the biggest thing is you get dust clouds that impact each other, and those form stars.
Yeah, anything that like a shock wave can compress the dust together, and then you get star forming.
And dust clouds are big enough that they might actually hit each other, unlike stars, which are like, I guess, BBs being fired, at each other across maybe California.
Go ahead with Janie's comment.
Oh, there you go. I always appreciate your extensive research and clarifications. Well, thank you, Janie.
Thank you, Janie.
And Orion was huge last night between clouds and the Pleiades.
Oh, Pleiades. Okay. I'm going to go ahead with the ephemeris here. February 1st, the moon is on the equator, at ascending node, and at perigee, all at the same time. Venus and the moon are in conjunction that night. Venus is 2.3 degrees north of the moon. Also, Neptune and the moon are in conjunction. February 2nd is Groundhog Day. February 2nd is Groundhog Day. February 2nd is Groundhog Day.
Good morning, little campers.
February 3rd, Venus and Neptune are in conjunction. February 4th, Jupiter is stationary, or appears stationary. February 5th is the first quarter moon, and Uranus and the moon are in conjunction. February 6th, Jupiter and the moon are in conjunction. In fact, Jupiter is 5.5 degrees south of the moon, and the Pleiades star cluster is 0.5 degrees south of the moon. They didn't say anything about opposite or occultation.
Yeah,
but it's pretty darn close.
Yeah, usually when it's within a degree, they do say that there's occultation, but maybe just not anywhere in North America, because I'm pretty sure that my source is a North American source.
Could very well be.
I've never seen like descriptions that weren't U.S., Mexico, or Canada. So
North America, basically. All right, so that brings us to February 7th, which is the Friday night show. I'm exploring a crunchy topic. I'll tell you more about that near the end of our episode tonight. Find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. What inspires you the most for the coming week?
Okay.
I'm going to go with this one too.
Okay.
I keep wondering, what is or what will be the Everyday Spacer legacy? Everyday Spacer isn't me, nor is it us, nor is it strictly all of us. I would say that this idea can, go out to regular folks for a long, long time who are interested in participating in space exploration, science, and astronomy, and who live beyond us. Perhaps some brainstorming is needed. What would you do to keep Everyday Spacer going into the future? I would love to hear your comments.
Yep.
Go ahead.
Okay. If you or someone that has done something interesting involving space exploration, science, or astronomy, we'd love to share our live. Join us again next Friday, February 7th, where Pam will discuss a crunchy topic: lava tube living.
Yep. Fascinating stuff going out there. And I saw an article. I'm like, ooh, I want to talk about that.
And hopefully you won't find giant moonworms. If anyone's read that Major Matt Mason book, which probably there's like 2 other people who've ever read it. But
I just think Pleiades is hard to spell. I share as much as possible. Yes, thank you very much, Cliff. And hint, hint. You saw up here that we had James Owens. He's involved with sports, and I've already floated the idea of him coming and talking about sports in space.
Oh,
maybe sometime. He wants to get into some live shows and do some presentations. So yeah, James, we'd love to have you on our show.
It'd be kind of like a soccer, basketball type of thing.
Well, there's 3D. Already cool stuff. There's those guys who've gone up and jumped out of balloons and a couple other things, I think.
But imagine team sports where you're trying to score goals and stuff, but it's in 0G.
Yeah. He says we will talk about that.
Cool.
Yes, please.
Yeah.
All right, so let's do a shout out. Cliff was here, and Janie was here, and Scott was here. JY, thanks for joining us. I think that's your first time. Dawn was here. Yay. We said Janie, right?
Yep.
Do we got anybody else new? James was here.
James, yeah.
I think we got everybody.
Yep. Oh. Yeah.
Alpo Youth Group.
Oh, James is.
Thank you very much. Yes, I see your posts on Facebook, and I'm very, very grateful. So we will continue to watch for your comments. Anything else from you?
No, that'll do it for tonight.
I think I'm good. Thank you so much for being here with us. It's always a better show when it's you and us. So have a great week, folks, and we'll talk to you next week about lava tube living. Good night.
Good night.